that's basically the justification which I gave for part B. Angles in a cyclic quadrilateral. Now, a cyclic quadrilateral, we just have to focus on two words in here. The word cyclic and the word quadrilateral. Quadrilateral. Sorry. بس الماوس. It's her mistake, not mine. Okay, so the quadrilateral, when I say quadrilateral, it means it has four sides. And when I say cyclic, it means all four vertices have to be on the circumference. 1, 2, 3, 4. Okay, please don't use the facts of a cyclic quadrilateral unless your vertices are on the circumference. Make sure the first thing before using a cyclic quadrilateral, before considering a quadrilateral to be cyclic, is to have all four vertices on the circumference, as you can see in this figure. The fact. As you can see, the figure in here, it looks like a kite or something, or a boat, I don't know. All four vertices are on the circumference, so I can consider it to be cyclic. 1, 2, 3, 4. Sometimes it looks ugly and doesn't look like a quadrilateral. Just make sure that all your vertices are on the circumference, and that would make it cyclic. If it is cyclic, they say the fact, where's the fact? Yeah. The opposite angles in a cyclic quadrilateral add up to 180. When I say opposite, I mean not adjacent. So here, A plus B is 180, C plus D is 180. Definitely, for a quadrilateral in general, all the angles will add up to 360. This is a well-known fact. So every quadrilateral has this property that the angles add up to 360. What's special about a cyclic quadrilateral is that its opposite angles, like A and B in here, and C and D, add up to 180. Practice 4, as you can see, cyclic quadrilateral on the left. So X in here faces the 85, so it is supplementary to 85. They add up to 180 degrees, which makes angle X 95 degrees. On the other hand, Y and 110 again are opposites. So Y is the supplement and Y is 70. On the right, again, I'm expected to use cyclic quadrilaterals, as in we have four vertices on the circumference. Now the 70 is adjacent to R and P, so it's opposite to Q. So Q is the supplement of 70, which makes it 110 degrees. P in here is the supplement of 135, which makes it 45. So angle P is 45, just because we have a straight line in there. And the angle R is the supplement of P, and that makes it 135 degrees. Please, afterwards we have the discussion forum on Digital Campus. If there is anything not clear about it, if you think there's something I need to say in a different way, please mention that and we will discuss it. Tangents. So as a tangent, as we said, it's going to be perpendicular to the radius. I shouldn't have drawn my ugly drawing to start with because it's here. So you have a radius, a tangent, the angle between them is 90 degrees. So that's facts. Now let's start to do some solving. They say if OT is a radius and AB is a tangent, the first thing I'm thinking of is an angle of 90 degrees here at T. Find the unknown angles giving reasons for your answers. As I marked my 90 degrees, there's something very clear in here, which is angle X. Angle X is what is left from the 180 degrees. So angle X would be 54 degrees. Angle Y, as you can see, if you extend its sides, you're going to notice that angle Y faces the diameter. So angle Y is 90. And subsequently, you can say that angle Z is what's left, 60. Practice 4. Now, they've become more serious right now, as you can see. So this might be a typical past paper question. If you look at this, the first thing I would look at if I were in your place is the cyclic quadrilateral. It's sometimes not clear, but it is something you need to look for first, I would say. As you can see, 4 vertices on the circumference, 1, 2, 3, 4. What's the supplement of 110? Supplement of 110, let me mark it in a different color. It's this. Supplement of 110 is W plus 48, this angle. This is 70 degrees as it is the supplement of 110, which makes W 70 degrees minus 48 degrees, which is equal to 22 degrees. Angle X, since they said PR is a tangent, so the angle in here, all of this is 90 degrees, which is W plus X. So X will be 90 minus W. And W is 22. Okay, this is the ugly, those are the two ugliest twos ever. You can agree on that. Okay, 68 degrees. Angle Y. Well, basically, this is also something we need to learn a bit. Angle Y and angle Z. We still have 2 angles to find. All right, so angle Y is not on the circle. So if angle Y is not on the circle, then we cannot apply any of the circle theorems that we used before. The only thing we can look at is this quadrilateral PUOR, and pay attention, this is also not cyclic. So basically I would have to rely on one property only, which is the angles add up to 360 degrees. I know I got a 90 in here at PRO. I got another 90 at, 1 second, need to grab the pen again. I have another 90 in here. So 180 already gone. So if I know this angle in here, which is UOR, I would be able to know why, because they add up all to 360. So again, isosceles triangles, you need to see them in circles. Radius equal radius. W in here was 22. I got another 22 in here. That tells me that this angle in here is 100 minus twice 22, and this should give me 136. Because 180 minus 44, yeah. And thus, you can find from this angle, which is, it solved my problems, I can find Y, I can find Z. Y is the supplement, because already we have 180 gone. Subtract another 136, and it should be 44 degrees. So y will be 44 degrees, while z is the inscribed angle that faces the same arc as the 136. So this is the same arc, UR. Angle Z and the 136 degrees, UOR, they all both face the same arc. Z is the inscribed angle, it's half of the central angle. So it's going to be 68 degrees. So as you can see here, we dealt with cyclic quadrilaterals. We dealt with a quadrilateral who has one vertex outside, so we dealt with the idea that we have a sum of 360 degrees. We dealt with the radius being perpendicular to the tangent, which makes 90 degrees. We also worked on isosceles triangles inside, always look for that, and the inscribed being half of the central. Typical question, IGCSE, beautiful question, I would say. Okay, I will leave this exercise for you to do on your own. No answers because this video needs to finish. And this is the overall. This is the page where you refer to know what exactly is required within the syllabus. Angles, if they are both at the circumference, if they are both inscribed and they face the same arc, then they are equal. If the angle, the inscribed angle faces the diameter, it's equal to 90 degrees. Cyclic quadrilateral, which means the quadrilateral has all four vertices on the circumference. It has its opposite angles adding up to 180 degrees. Opposite are the non-adjacent. This is one pair I just marked. And the radius and the tangent are perpendicular. If we have also the last one, if in this case, for example, we have an angle whose vertex at the center, another angle whose vertex at the circumference, they both face the same arc AB. The one at the circumference is equal to half the one at the center. After this video, I'll be assigning a worksheet for you to work on, and then we'll be posting answers, and in addition to a small quiz that you're expected to do. Thank you so much, and good luck.